Hello community! Today we make an experimental video about Stable Diffusion XL. Now, I have not touched SDXL in my life, so welcome! This is a real-world experience. How can we generate any kind of image from a text-to-image AI system like Stable Diffusion XL? Now, easiest thing to do, Stability AI, clip drop. You just go to clipdrop.co, Stable Diffusion. There are all the other tools. You have a cleanup. Let's have a look at this. So Stable Diffusion is here. You have uncrop, reimagine, a doodle, a cleanup, remove the background, everything. And you have here with Stable Diffusion XL, I think you have 1 or 2 images free. So you enter your prompt, or maybe you go to the style, you say, hey, photographic, cinematic, pixel art, isometric, and you have your aspect ratio, you write some negative prompt, and you say generate. Beautiful. Now, of course, this is only for demonstration and works only for 1 or 2 images. Pricing, yeah, of course. Free, 0, Pro, $7 a month, or additional. Great. So what about you want to be a little bit more professional? Now, I just found here StableDiffusionWeb.com, Stable Diffusion XL demo. Beautiful. So here we enter here a prompt. You enter a negative prompt. You say the width and the height of your image, the guidance scale, the steps, the seed, and you say generate. This is it. As you see, I put here in a very simple prompt, and I did this about 300 seconds ago, and I have to wait, I guess, another 500 to 1000 seconds because everybody is trying this out for free. So great. Now, before we dive into a COLAB code, let's say Stable Diffusion, yes, a little bit of theory, and you say, what is Stable Diffusion? Well, don't worry, because if you go here to my channel, Code for AI, and you enter here Stable Diffusion, this is very easy. This is the result you get. I have a playlist with 19 videos on Stable Diffusion. I have here in PyTorch, here variational autoencoder, UNAT, clip. Beautiful. What else? Yeah, here I have a multi-parallel 8x parallel pipeline for the ultimate speed in Stable Diffusion in Flags. So this is here a TPU implementation of Stable Diffusion, but I do not know the web user interface, this XL. I just know the theory and the code, but I have never experienced the user interface. What else? Yeah, Stable Diffusion in Paint. I showed you this 10 months ago. What else? Unboxing. Here we have a new COLAB Notebook where we code Stable Diffusion, and we do not use a web interface. But hey, today we are so much more advanced in our technology. If you want to understand Stable Diffusion, I would recommend these 2 videos to you. So the 2 amazing ideas in latent diffusion models here with variational autoencoders, UNAT, clip, the generative AI, the physics behind this. Or if you want even understand a little bit more complicated, the vector quantized variational autoencoders for image generation as a deep dive into the theory. And of course, if you are interested here, how is it possible to go from some images that the system learned to a newly generated image? I have here before diffusion, what could we do with variational autoencoders explained here with the Kullback-Leibler divergence that we will use here, or did use here 10 months ago. But this is history. We're not interested in history. What we can do if we are a complete newbie. I have no idea what a web UI is here by Stable Diffusion. But you know, and I know that automatic is here maybe the place to go. So make it a little bit bigger, automatic 1111, Stable Diffusion Web UI, beautiful. There you have the code. You now just know this text to image or image to image or whatever you want. And here's some simple sliders. You have the features and you can make a deep dive. Now I would like to do this now today from a completely newcomer. I don't know nothing about this UI, which is true, I don't. So I go here to the last Ben, GitHub, and I say fast stable diffusion. And what I like here is the possibility to run here the A1111 and Dreambooth and whatever. We have here notebooks you can run on RunPod, or you go to Paperspace, or we go to COLAB, or with Automatic 1111, or we go to Dreambooth. So I choose today to show you here the free COLAB version here, the web user interface here for this text to image generation based on stable diffusion. So we click on this, we load it here, and here we have it, our COLAB Pro notebook, which is just a COLAB notebook. I do not pay for this. I want that you are able to generate this free of charge. So as I told you, my source is GitHub The Last Pen. Please go to your preferred choice, but maybe you give this a try. Alternatively, you can do this on a RunPod, on Paperspace. I go here for my Google Drive. So let's start this here. I hope we get a T4 at least. We are connecting, we are initializing. Yes, we have a T4. So here on the right hand side, you see the system RAM, the GPU RAM, and our disk space. Great. So let's do this. Connecting done. Next thing is install update the repo. Beautiful. This is what we're gonna need. Yes, yes, yes. Everything has been taken care of. Great. I will do this here in real time, that you see that sometimes it takes quite some time for everything to upload. Done, requirements. And then the next thing is here, the model download. Make sure you have enough space. Yeah, it should be fine. Installing requirement. We go with the simplest SDXL version. Let's say here. Model download, it's gonna take some time, still installing the requirements. Yeah, you could use some adaptation. We will not go with LoRa, we will do here a plain and simple and basic and vanilla SDXL. There are a lot of options. We can optimize here the space and the memory imprint here, but we will be here vanilla today. So as you can see, model download, we have about 7 gigabytes that we have to download from Hugging Face, Stability AI, Stable Diffusion, XL, the base model, the 1.0 model. The base model with safe tensors, great. So should take about 30 seconds to download 7G. LoRa, I don't think we're gonna use LoRa. Maybe we can do this here. Yeah, let's see. 1 second, 2 seconds, done. Let's see if the default of LoRa is done. Yes. Control net, no. And then we're gonna start stable diffusion. Do we Cloudflare? No, we just start here the simplest version of stable diffusion. Yippee! So here we go. Then start stable diffusion. This is what we are looking for. Takes a little bit of time. Our system RAM is up a touch. GPU RAM is still sleeping. Disk used some spaces, but this is great. So downloading, okay, pre-trained Liberty checkpoint, okay, authentication, yes, control node preprocessor, calculating, okay. And here we go, ladies and gentlemen, here we have now our Gradio link, our public URL, this is all that we need. So let's do this, open link in new tab, and let's go there. And there you should have it, your personal copy of Stable Diffusion XL running here on your COLAB free notebook account. Beautiful. Now, of course, we go here with the simplest checkpoints. Do we have anything else? No, we only have one checkpoint. Okay, so here we are. And the first thing is text to image, image to image, extra. Yeah, let's start with the very beginning. We are here absolutely newcomers, so a prompt. So here we go. I say here, a complex DNA strand with some synthetic robotic molecules attached. And in the negative prompt, I say no sketch, no draft, no low resolution drawing. I want something really nice. So we go here with this simplest generation sampling method. Let's see what this is. Okay, maybe I go with Euler. Sampling steps for denoising, I suppose. Yeah, a little bit, 45. Let's see what this will bring up. High resolution. Should we do some high resolution? Well, yeah, let's see. Refiner, no, width 512, 512. Batch size, okay. Batch count, seed, yeah, script. So I think first try, this is it. This is what we want to do with text to image processing, generate. Waiting, yeah. Now, of course, waiting is okay. So we are downloading here in our COLAB Notebook. You can see here, model is loaded. We have here downloading the variational autoencoder approximation. Yes, this is done. And now we are here. 100% of those steps, 100% here. So we are waiting for performance. As you see, system RAM is up, GPU RAM is, oh yeah, it's yellow, yippee. But we have 15 gigabytes of VRAM. So let's cross the finger that this is enough for our prompt and for our resolution. I see no problem at all. Disk space is until now plenty. Looks good to me. So 28%, 30%, 33%. Yeah, let's have a look here at our web user interface from Gradio. And you see, my goodness, this is not what we were thinking about. This is just simple, plain, not usable. But we wait, so expected time of arrival, 19 seconds. We do this in real time that you get a feeling how complicated it is. But this is not what we are looking for. So there you have it now. After 46 sampling steps, this is now an image that we get. These are two images that we get. Okay, this is one and this is two. Hey, what do you think about this one? A cityscape with an ultra-detailed photorealistic resolution and form. A futuristic city covered by a living mesh of trees and flowers. Let's do this one. I hope it's not another sketch. Okay, looks a little bit better for me, yes. Uh-oh. Oh yeah, here we go. So, first one. Okay. Second one. Yeah, you get the idea. Yeah, let's do this a little bit with a little bit better resolution. Let's go sampling, I don't know, Euler 8. Sampling step, maybe we go to 70 and we do it again. Just to show you the difference. And I have no idea, I don't know this user interface, I have no idea what are default values on the sliders. So, absolute newcomer to this. Hey, just 6 minutes, 5 minutes, expected time of arrival, 4 minutes. Yeah, it's improving. So I will be back with you in about 3 minutes to show you the result. And here we go, this is it. After 3 minutes, we have these two images. Okay, it's quite nice, I think. Okay, this is number one. This is number two. Yeah, we can download it. Okay, not that bad. Okay. So again, we have here now a specific prompt. I say, okay, I have no negative prompt. I just say generate. Have a look here. Sampling steps here. We go with the simplest 512 pixel times 512 pixels. Batch size, yeah, let's increase to 2. Let's do the follower parameter to your text, increase a little bit. Okay, so this goes really fast here for a 512 times 512. And you can download this not to your COLAB notebook if, so this is a very simple result, but if you have, for example, we can increase here the size of the steps. a better GPU than a T4 on the free COLAB Notebook. If you have more than 15 gigabytes of VRAM, please download this to your local PC. If you have 20 or 24 gigabytes of VRAM, go with your local implementation and you should have no limitations at all. There are a lot of options to find out about this. So why not give it a try? And we do a second now generation. We increase the number of the sampling steps. We increased a little bit the size of the image. You could use here an upscaler, of course, but we are not gonna do an upscaler right now. And as you can see, it tells us expected time of arrival about 7 to 8 minutes, maybe just 6 minutes. And let's have a look what we did here with this particular prompt. Covered with a living mesh of trees and flowers. This is what I'm interested in. This is why I increased the CFG scale, the follow scale, that it really follow here my textual description more stronger. So, yeah, here we go with the first draft. 17% already calculated, 18%. So let's see. Yeah, this looks green. If there would be a mesh now on these images, we achieved what we set out to do. You can upload this to any cloud infrastructure you would like. This is the very nice thing, as I showed you here. You can run it on run pods. You can go with paper source. Choose your preferred cloud infrastructure. Let's just wait here some seconds to see here the quality of the image as it increases gradually. You see more and more details are computed here, and we adjusted 1/3 of the calculations for Stable Diffusion XL. Yeah, as I told you, if you go to the internet, you find a lot of other checkpoints for Stable Diffusion. There are model-specific checkpoints, there are topic-specific things where people invested days and weeks and months to optimize their model, to optimize here the prompt structure, to optimize here the negative prompt, to optimize here all the sampling steps. So if you make a deep dive, if you either downloaded it to a free COLAB notebook, I've shown you with 15 gigabytes of VRAM, you can run it here on a free COLAB. If you pay for the COLAB Pro version, it will go even faster, and your models can be much more complicated and complex in its structure. So we are here now at 62%. And as you can see here, we got some images that resemble here my idea. It's not really covered with a mesh of trees and flowers, but okay. You remember we have to have training images where this system can combine existing training images. If we have no image with a city covered by a living mesh of trees, of course, then the composition, or better, the denoising composition is not as easy. So try to use here items that you are sure that there has been some images in the training dataset for this particular application. And then it is so much easier. We are close to 87%. And so here we are with the result. Okay, you might say not so impressive. The mesh is rather here, yeah, you know, whatever this should be. But I think here for a free version, there's the mesh. I see what it did. It's like a fisher net. This is the mesh. Oh, I get it. Okay, so as you see, and why not go with a little bit more advanced positive prompt and a negative prompt? Let's say generate. Let's see if our free COLAB notebook is able to do this. Doesn't look too good because, yeah, we have 4% expected time of arrival, 4 minutes, 3 minutes. So I see you back in 3 minutes. So let's have a look at the two images generated with a little bit more advanced prompting. So here we have them. Yep, looking good to me. If we would increase the resolution, if we would increase the file size, this could be something really nice. And you might ask, hey, where did you get this idea of a prompt? Well, as I told you, the internet is full of this. Have a look here. If, for example, you go here with this particular image, you have here a prompt here, text to an image prompt here. You just can copy here. Or you go here with the negative prompt, you see this here. You have the sampler, you have the CFG scale, the steps, the seed, copy the generation data. And as you can see, where did I found it here? On the internet, go wherever you like, whatever you need. I just have here gallery, newest, and here example. This is what catched my eye. So I said, hey, great. So I go there. Resources used. You can download here the model. Oh, wow, neo science fiction. Okay, whatever there is. Download 144 MB, run the model, verified, safe tensor, type LoRa, download 7000 June. Base model, SD, steps 4000. Training, okay, one file. Here you have your LoRa file. The reviews about this version, great. So as you can see, go on the internet. If you like an image, have a look at the prompt, have a look at the model if you can download it, and go and why not optimize the hell out of this machine. It runs on a free COLAB, or you download it here for your particular use on your PC. Experiment with codes. There are a lot of resources. I hope it was instructive. I hope you get an idea. Maybe if you're completely new to this SDXL web user interface like I am, this was today my first time exploring this. But there are a lot of beautiful resources on the internet. So why not give it a try yourself? Would be great to see you in my next video.